In this video, we'll look at section 1-7, logical reasoning and counterexamples. So this type of content is really troublesome for some people because logical reasoning hasn't really been enforced a whole lot throughout the curriculums. So this is to really take that to the next step. So we're going to take a step away from actual math concepts like adding, subtracting, multiplying, dividing like that, and look at thinking. Okay, we're going to look at how to think in a logical sense. So first stuff we need to know is just a conditional statement. A conditional statement is written in the form if A, then B. Okay, so they're called if-then statements. So in this situation, if the popcorn burns, then the heat was too high or the kernels heated unevenly. Okay, so the first part, the part after the word if, is called the hypothesis. Okay, if is not a part of the hypothesis, it's just the identifier. The part after then, the word then, is called the conclusion. So if whatever the hypothesis, then the conclusion. Okay, so that's what we're looking at. So we're looking at if-then statements, if this, then that. All right, so first, identify the hypothesis and conclusion of each statement. So I'm going to use red and green. So hypothesis in red, and then green will be conclusions. So remember, if it is Friday, so then Ophelia and Miguel are going to the movies. So the parts after if are the hypothesis. So if it is Friday, so it is Friday, that's the conclusion, or that's the hypothesis. The conclusion you'd come to would be, well, Ophelia and Miguel are going to the movies. So it's after the word then. That's what we're looking at doing. So now, same thing. If 4x plus 3 is greater than 27, then x is greater than 6. Okay. So the part after the word if. So 4x plus 3 is greater than 27, then x must be greater than 6. So that's what we're looking at doing. All right. So let's continue with the same thought process. If it is warm this afternoon, then we will have a party outside. Okay. So you're setting up a situation. You're telling someone, if it's warm, then we'll have a party outside. Okay, so after the word if is the hypothesis, after the word then is the conclusion. That's what we're looking at doing. All right, so then if 8w minus 5 is equal to 11, then w is equal to 2. So again, if 8w minus 5 is equal to 11, then w is equal to 2. So right now we're just looking at identifying and setting up conditional statements. So now identify the hypothesis and conclusion of each statement, then write each statement in if-then form. So this is where it gets a little bit trickier because it's not in if-then form. Now it says identify the hypothesis and conclusion right away, but I would say change to if-then form and then flip it. Okay. So what part is kind of more dependent on the other is what you got to ask yourself. So I will go to the ball game. So just think about, you can say it multiple ways. If I go to the ball game, then it is Saturday. Okay, well, that doesn't make a whole lot of sense. But if you're to switch it, if it is Saturday, well, then I'll go to the ball game with you. That makes a little bit more logical sense of how you'd set up that conditional thought process. So if it is sat, I'm going to abbreviate, then I will go to the ball game with you. Okay, so that makes a little bit more sense. So now we can identify the hypothesis. Well, if it is Saturday, our conclusion would be, I will go to the ball game with you. Oh, I forgot with you, the part. With you. There we go. It's a little better. Okay, so it's easier to set it up first. So for such a number x, for a number x such that 6x minus 8 equals 16, x is equal to 4. So we can kind of take an example from the last one. They always did the main equation first. So if 6x minus 8 is equal to 16, then x equals 4. So once again, if the hypothesis 6x minus 8 is equal to 16, then x equals 4. Okay? So I would say it's always easier to set up the if-then first. So always try to think which one sounds a lot more logical. Okay? And it takes practice to do. I've done this for years. Over time, you will do it. Okay, so now, deductive reasoning. This is where people struggle. Deductive reasoning is using facts, rules, definitions, or properties to reach a valid conclusion. And that's kind of what we've been already doing. We've just been looking at the conditional statement. So, think of an apple. If I drop an apple, it will fall. That's based on the fact or the rule of gravity. Okay, so that's using deductive reasoning. I'm planning it out based on a rule. So now, if we're given a statement, okay, we're going to determine whether we can form a valid conclusion. All right, so if not, then we'll just say no and explain why. So if two numbers are odd, then their sum is even. And we can, this is a rule. This is a statement of fact. Okay, so we have two numbers, odd. We can, just think about it. 1 plus 3, 4. 7 plus 4, 11. Or sorry, that doesn't, they're not both odd. Sorry about that one. 7 plus 3, there we go, is equal to 10. Okay, so the sum was always even. So now, let's think about this. The two numbers given are 7 and 3. I just gave this one away by chance. Okay, these two numbers are both odd. Can we assume that their sum will be even? Yes, absolutely. Okay. So, we can say the sum will be even. Okay, because the 7 and 3 are both odd. And given this is 100% true, given this is true, being given two odd numbers, that will give us a true statement. Okay, the next one. The sum of the numbers is 14. So we're given the conclusion. Well, their sum is 14. Well, does that necessarily mean the two numbers, whatever we're given, are odd? No. The numbers could be 10 and 4. So we don't know. So there's no valid conclusion we can come up with. And you only need one idea. So numbers could be 10 and 4. Just need one example of why we can't. Okay, so that's what we're looking at. So let's do no. So there's a statement. There will be a quiz every Wednesday. So if I came to you in class and said, there will be a quiz every single Wednesday, what could you conclude from the following statements? You wake up and you go, it is Wednesday. What could you conclude? Remember, this statement is 100% true. Okay, all I'm telling you is every Wednesday there will be a quiz, no matter what. You wake up, it is Wednesday. That tells you there will be a quiz. The second one, it is Tuesday. So like I said, there will be a quiz every Wednesday. It is Tuesday. What can you know? Do you know, no, there's no way he's going to give a quiz because he said there will be a quiz Wednesday. But I never said only on Wednesdays. So on Tuesdays, I could still throw a quiz at you. So you don't know what's going to happen. So there's no valid conclusion because I could still give you one. Okay. There could still be a quiz. All right. So now, last little thing we're going to talk about is counterexamples. A specific case in which the hypothesis is true and the conclusion is false. So, Rachel believes that if x divided by y is equal to 1, then x and y are whole numbers. Okay, Jose states that this theory is not always true. Which pairs of values for x and y could Jose use to disprove Rachel's theory? So remember, the hypothesis remains true that we still divide the two numbers, but the conclusion would be false. So x and y are not whole numbers. Okay, so let's look. So we have x equals 2, y equals 2, x equals 1.2, y equals 0.6, x equals 0.25, y equals 0.25, and D, x equals 6, y equals 3. So just looking at this, we want the conclusion to be false. So right when you look at it, well, we know A and D, those are whole numbers. 2, 6, and 3 are all whole numbers. So it can't be those. So then, remember, we need the hypothesis to be true. So in B, we have 1.2 divided by 0.6. Well, that's 2, so it doesn't equal 1. So the hypothesis in that one is false. But 0.25 divided by 0.25, that is 1. So our answer is C. X equals 0.25, y equals 0.25, because when you divide them, you get 1, and they're both not whole numbers. And when it comes to counterexamples, you only need one case, one example. So which numbers disprove the statement below? If x plus y is greater than x times y, then x is greater than y. So this one you can kind of do process of elimination. If you plug in, we're going to start with f. So 1 plus 2 is greater than 1 times 2, and then we want x to be less than y. We want the false part. Okay, so does this work? 3 is greater than 2, true, and is 1 true, and then 1 is greater than 2, that is false. Well, that one works right away. So we want x to be smaller than y, so that one seems to work. Let's keep going. Okay, let's double check. So 2 plus 3 is greater than 2 times 3. So 5 is greater than 6. Well, nope, that doesn't work. Okay, no. So that's false. So that one fails right away, because we need the hypothesis to be true. The next one, I'm going to run out of room here, so I'm just doing colors. So we get 4 plus 1 is greater than 4 times 1. So we have 5 is greater than 1. Or excuse me, 4, that's true. But 5 is also greater than, or excuse me, 4 is also greater than 1. But that's true, we don't want that one. So that one doesn't work. I forgot to cross off the red. And let's double check the last one. So we have 4 plus 2 is greater than 4 times 2. That is 6 is greater than 8. That is false. So that one doesn't work. So our original check was right. So our answer is F.